In this video, we're going to be taking a look at identifying integers and their opposites. Now you will need to get out your Go Math book and turn to page 7, get out your math journal, and also a pencil. Now the essential question we will look at is at the top of page 7, and that is, how do you identify an integer and its opposite? So we'll first of all take a look at Explore Activity 1, and I want you to follow along with me on page 7 of your Go Math book. So you can see at the top it says positive and negative numbers. We're going to take a look at positive and negative numbers and just go over a couple basic ideas surrounding positive and negative numbers. First of all, you can see at the top, positive numbers are numbers greater than 0. Positive numbers can be written with or without a plus sign. You can see an example, 3 is the same as plus 3. So whenever you have a number such as 3 and there's not a positive nor a negative in front of that, it's understood as 3. For example, if I were to ask you your favorite number, for example, my favorite number is 24, I would not write plus 24 to make sure that it's a positive 24 necessarily. I would just write 24 there and you would understand that it's positive. As far as negative numbers, they're numbers less than 0. So negative numbers must always be written with a negative sign. So unlike positive numbers, you need to have a symbol in front of it to make sure we know that it is negative. So if I have the number 3 there, and it's a negative number, I have to write -3 or -3. Basic idea in terms of a number line, you can see positive numbers are to the right of the 0 on the number line, and negative numbers all fall to the left of the 0 on the number line. Now you can see here on the upper right-hand corner of page 7, the number 0 is neither positive nor negative. So we feel very bad for 0, but 0 is neither positive nor negative, and I think 0 is fine with that. Now let's move down page 7, and it says the elevation of a location describes its height above or below sea level. Now it's important to know that sea level has an elevation of 0. So elevations below sea level are represented by negative numbers, and an elevation above sea level are represented by positive numbers. So we have a graph here. It says the table shows the elevations of several locations in a state park. Graph the locations on the number line according to their elevation. So let's do this together. So we can see location A has an elevation of 5 feet. So there's not a plus nor a minus in front of that 5, which means it is a positive 5. So 5 above sea level. We'll just plot our point right there on the graph. The next one, section or location B, Cradle Creek, is -5. So in other words, that's 5 feet below sea level. So we'll put our point right there on the graph. You see it's -5. It's left of the 0. Dinosaur Valley, -9. You can see -9 on the number line. We can even start at that 0 and go 9 spaces to the left of that 0 is -9. Mesa Ridge is 8. There's not a positive nor a negative, so we know it is +8. Right there on the number line. And Juniper Trail, -3. So 3 feet below sea level. We start at our 0, go 1, 2, 3 numbers to the left. So we have our -3. And I do want you to put those points on page 7 as well. So let's take a look at letter B together. It says, what point on the number line represents sea level? So we went over this a little bit earlier, but sea level actually is represented by the number 0. So we'll put 0 right there on page 7. I want you to do that as well. Next one, which location is closest to sea level and how do you know? Now they're not asking above or below, just closest to sea level. So we can see right here, -3 feet below sea level, or -3 on our number line below sea level is the closest. So we can see that Juniper Trail, we'll write that in here. So we can see that Juniper Trail, I want you to write that in, is closest to sea level, and we know that because its elevation is closest to 0 on the number line. So we can see Juniper Trail, -3 on the number line, is closest to 0 on that number line. Now letter D. Which two locations are the same distance from sea level? Are these locations above or below sea level? Now we can see that Little Butte is 5 above sea level. Cradle Creek is -5 below sea level. So these locations are the same distance from sea level. And then finally, letter E. Which location has the least elevation, and how do you know? We can see Dinosaur Valley has the least elevation. We know it's -9 or 9 below sea level, 9 feet below sea level. And the reason we know that just by looking on the number line, its elevation is farthest left on that number line. You can see there's not any number going any farther left than Dinosaur Valley. Now let's turn over to page 8 in your Go Math book, and we can see the reflect problems. Number 1, Morning Glory Stream is 7 feet below sea level. What number represents the elevation of Morning Glory Stream? And I want you to complete this problem all by yourself. Okay, you should have had -7. The reason we know that, if you look back at page 7, elevations below sea level are represented by negative numbers, and elevations above sea level are represented by positive numbers. So -7 should be your answer. Now let's take a look at number 2. It says explain how to graph the elevation of Morning Glory Stream on a number line. And I want you to write this down for number 2. The way you would do that is graph a point 7 units to the left of 0 on the number line. If you remember from the previous page, numbers to the left of the 0 represent negative numbers, and numbers to the right of the 0 on the number line are positive numbers. Now let's take a look at Explore Activity number 2, titled Opposites, on page 8. Now we have two numbers are opposites if on a number line they are the same distance from 0, but on different sides of 0. For example, 5 and -5 are opposites. 0 is its own opposite. So I'm taking a look at 5 and -5. Think about both of these numbers are the same distance from 0 on the number line. One just happens to be the left, and one just happens to be the right. So if we're taking a look at integers, integers are the set of all whole numbers and their opposites. Okay, so we can see there on page 8, remember the set of whole numbers is 0, 1, 2, 3, 4, 5, 6, and so on, and also their opposites. Now on page 8, it says on a graph paper, use a ruler or straight edge to draw a number line. You can just do this right in your math journal. And I want you to label the number line with each integer from -10 all the way to 10. And you can just copy mine right down at the bottom of the page if you would like. Don't worry about folding the number line in half or anything like that. Okay, so what we want to do is use your number line to find the opposite of 7, -6, 1, and 9. So if we take a look at 7, we can plot our point. The opposite of 7 would be -7. Why do we know that? Because we can see 7 is 7 to the right of the 0 on the number line. -7 is 7 to the left on the number line. Let's take a look at -6. We can find -6 on our number line. The opposite of -6 would be 6 to the right on the number line, so it would be +6. So we can have -7. We can have regular 6 or +6. Now as far as 1, we can find 1 on the number line there. The opposite of 1 would be -1 because it's 1 to the left of 0. +1 is 1 place to the right of 0. So we can have -1 there. And what I want you to do is find the opposite of 9 on the number line and write it on letter A for your answer. And you should have -9 for your answer. Okay, let's take a look at number 3, and I want you to write this down in your Go Math book. It says explain how your number line shows that 8 and -8 are opposites. So you can see we have 8 and -8. They're the same distance from 0, but on different sides of 0. So I can see that -8 is -8 away from 0, and +8 is also 8 places from 0, but on different sides. Now let's take a look at page 9 at the real world example for this lesson. We can see positive and negative numbers can be used to represent real world quantities. For example, 3 can represent a temperature that is 3 degrees Fahrenheit above zero, and negative 3 can represent a temperature that is 3 degrees Fahrenheit below zero. Both 3 and negative 3 are units from zero. If we take a look at this example, so we see Sandy kept track of the weekly low temperature in her town for several weeks. The table shows the low temperature in Fahrenheit for each week. So section A, graph the temperature from week 3 and its opposite on the number line. What do the numbers represent? So we can see step 1, graph the value from week 3 on the number line. So we see week 3 is negative 4 degrees below zero. And we also see the opposite of that would be 4 degrees above zero. We see negative 4 places below zero, and 4 is 4 places above zero as well. That's the opposite, would be positive 4. Section B, it says the value for week 5 is the opposite of the value from week 1. What was the low temperature in week 5? So first of all, for step 1, it says graph the value from week 1 on the number line. So the value from week 1 is negative 1. We can do that, even together there. And also the graph the opposite of negative 1, which would be positive 1. And then step 3, graph the opposite of 1. All right, so we're trying to find the opposite of the opposite. So the opposite of 1 is negative 1. So we see the low temperature in week 5 was negative 1. So now if we're taking a look at number 5 on page 9, it says explain how you can find the opposite of any number without using a number line. So we can see the opposite of a number is the number itself. Just like the opposite of negative 1 was negative 1, the opposite of 8 would be 8, so it's always that number itself. Okay, I want you to turn to page 10 in your Go Math book. We're going to just do a few of these problems, not all of these problems together in this video. Or I'll have you do it by yourself in the video. So number 6, graph the opposite of the number shown on the number line. So graph the opposite of negative 1. I want you to do that now. Okay, and you should have 1. Now I want you to complete number 9 all by yourself. And you should have positive 5. I want you to complete number 10 all by yourself. And you should have 0 for your answer. And finally, I want you to complete number 11 all by yourself. What is the opposite of 6? So you can see the opposite of 6 is 6. Remember, the opposite of any number is always that number. Okay, and then wrapping up the video for number 11, given an integer, how do you find its opposite? You can write this down on page 10. Find the integer that is the same distance from 0, but on the other side of 0. So this concludes the video on identifying integers and their opposites. If you have any questions about this concept, please come and see me.